Hey guys, today is March the 4th, and I'm gonna do another LeetCode Daily challenge. Been feeling kind of depressed lately because I haven't been able to get the problems, but it's okay. Just continue to work on it, I guess. Anyways, 2579, count total number of colored cells. There exists an infinitely large two-dimensional grid of uncolored unit cells. You are given a positive integer n, indicating that you must do the following routine for n minutes. At the first minute, color any arbitrary unit cell blue. Every minute thereafter, color blue every uncolored cell that touches a blue cell. Below is a pictorial representation of the state of the grid after 1, 2, 3 minutes. Okay, just off reading that, that's kind of like a BFS, right? Return the number of colored cells at the end of n minutes. Okay. So there is no like actual grid in this problem. Like we can think of it as a grid, but I think I don't think we're actually going to be coding out like a two-dimensional grid and then running BFS. I think this is more like math, right? Something like that. I don't know. So like right now I'm just thinking like what tool can I use to maybe solve the problem? I have no clue what the answer would be. And since it's like super large, right? Like n can be super large, then I think we're not actually going to build a grid, probably some dynamic programming. This might be a stretch, but let me draw something out. Maybe I could find a pattern. Because what I'm thinking, and I don't know if this is correct, but I kind of see a pattern. Like for n is 1, obviously there's only one cube, right? So we kind of just make the cube like you see, and then we just give it like this cross type thing, and that will become 2. Now, when n is 2, we're going to fill up the square, like create the cube again, and then we're going to have it protrude out this, right? And that's n equals 3. And then I think for n equals 4, we probably need to draw out the cube and then give it like this. So what I'm gonna do here is just return 0, just because I want to double check what I'm thinking. And I want to see what n equals 4 is. So the way I'm saying we should do it, I'm expecting, let me see. I am expecting 1, 2, 3, 4, 5 by 5. So that's 25 plus 4, because 1 on each side. So I'm expecting 29 when n is equal to 4. And if that's correct, maybe I could start somewhere. If not, I really have no clue. When n is 4, Wait, what? Wait, I'm a little confused because just taking their example, what would n equals 4 be? Why would n equals 4 be 25? If each of these had some adjacent, we could fill it in, right? We can do this. Oh, we can't do this one. Interesting. So it would look like that, right? It would look like this. Then it would look like this. Wait, and then it has these ones, of course, right? What is this? 1, 2, 3, 4, 5 by 3, that's 15. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so there's all 25. Looks super weird, I don't know. Okay, so then I guess another thing I could try is just writing out and then seeing if I see a pattern. Because usually with dynamic programming, you would see a pattern, like, and it's an equation, right? Like a recurrence relation. So maybe I could see a relation with that. We'll see. Because I have like zero confidence right now. So with one, there's one. When n is 2, the answer is 5. 3 gives, what is this? This is 9, 10, 11, 12, 13. So there's 13. And then 4, like we said, was 25, right? The difference between this is 12. The difference between this is 8. And then the difference between 1 and 5 is 4. So that's kind of a pattern. I mean, like this, I'm doing this so bad, but at least I feel like there might be a pattern. What would 5 be then? So if there was 4, then this is 8. That's kind of like 4 times. So that's like 4 squared. No. Wait, so that's 4 plus 4 is 8 plus 4 is 12 plus 4 would be 16. So the difference between these would be 16. So 25 plus 16 is 41. Okay, this is super hacky, but hopefully that would work. That would be cool. And then maybe I would I don't know, maybe I'm just lucky. 41. Oh, okay. So we found a pattern and I don't know how that works, but let's use it now. Okay, we're like 11 minutes in, no code, no idea how to do this. Let's try. Okay. So I guess we're gonna start with maybe like I don't know what to call it because I don't even know what I'm doing. Like a running offset? I don't know. Maybe I'll just call it maybe I'll just call it running and we start with 4. So this is going to be running right over here. And then the 1, 5, 13, 25, that's going to be that's the colored cells, right? So cell count is equal to 1. Maybe I have a base case as well if well, we'll see. So for I in range n and minus 1 maybe. Let me just do this and then return cell count. The cell count is equal to everything before it plus running. So that's going to be 1 plus 4, which is 5. And then later we have to make sure that it's 5 plus 8. So our running, which maybe I'm going to call it some sort of offset. That offset plus equals to 4. And then that's an offset right here. Then we just return the cell count. Okay, I think that's it. Let me just, because I don't know if my ranges are correct, let me just run through maybe what happens when we have n is 3, okay? So for I in range 2, so it's gonna go 0, 1, 2. It's gonna run 3 times. The first time, cell count is going to equal to 1 plus the offset, which is 4. So we're going to get a 5 right there. And then when it runs again, now we're going to get 5 plus the offset of 8. So then we're going to get 13. So we should actually stop right there. So it's n minus 2. Cool. Yeah, let me go ahead and run that. Wait, when n is equal to 2 for I in range. Actually, it might be n minus 1. Let me see. Okay, there it is. And then let's run that. Okay, that passed. Wow. Yeah, I guess sometimes, well, that's what I learned kind of. I don't know. I remember in college we had this one class. I don't know. I forget what it was called. It was like, but it had a lot of like recurrence relation problems. At some point, we just write out the first couple and see if you could see some sort of pattern. And in this case, I guess I was lucky to be able to see it. But actually explaining why this works, I have no clue, and that's something I will have to do some research on. But yeah. Thanks for watching, and I'm happy I was able to do it, but I don't know much about it. I still need to like think a little bit more into it. But yeah, just looking at patterns, I guess. So thanks for watching.